TI-Nspire here to draw a scatter graph and most importantly to work out the equation of linear regression. Also a nice little bonus, it's going to help us work out the mean of both sets of data, and we can easily take off the interquartile range from the calculator as well. So let's get to it. Turn the calculator on. We want a spreadsheet. We'll call this R and we'll call this T. And we just feed the values in. 1, 3, 4, 5, 8, 10, 13, 15, 17, 20. Go back up here. Now we've got to get the next data set in the same order because the 3 has to be paired with the 6, because if we were plotting this on a graph, 3 pairs with 6. So you can't change the order, otherwise things wouldn't be quite right. 2, 6, 9. 3, 11, 16, 15, 20, 25 and 23. And that really is your work all done. So I'm just going to work in this particular section here. I'm going to click on C1 and I'm going to ask to work out all the mean for monthly rainfall, the mean monthly temperature, and also the median and the quartiles, menu, statistics, statistical calculations. Oh, I think I went a bit too far. Try that again. Menu, statistics, stat calc, and it's 2 variables. Yeah, we've got monthly rainfall against temperature. And the drop-down menu, this is R is the X variable, and T is the Y variable, and it's going to throw the answers in column D.
Ready, boss?
Yeah, just doing a video, mate. Hold on a sec. And then just read off down. So X bar here represents the mean, and the X representation was for rainfall, so the answer here is 9.6. If we keep going down here, we've got the medians and quartiles. So for interquartile range of rainfall, rainfall was the X variable. So the lower quartile is 4, upper quartile is 15. 15 subtract 4 is 11. Now that saves you trying to find the midpoint, then halfway again and halfway again here. So that's quite a quick fix there. You can also scroll down, you've got the median for Y, the monthly temperature, and you've got the interquartile range for temperature as well, which is quite cool. But you also want the equation of linear regression, T in terms of R. So like, guys, I'm just doing a video, just 1 second, yeah. So if I go doc, insert a data and statistics, and all these points are from lots of data sets I've got on my spreadsheet, but I want here, I want R against T. Beautiful. So this is the scatter plot we kind of expect, you know, as the monthly rainfall increases, the monthly temperature seems to increase. I mean, I would question whether this is the right way around for plotting, but the question says find the equation of the linear regression line giving temperature in terms of rain. So does the rainfall determine what temperature it is, or was it the other way around? It doesn't really matter for the exam style question because it tells us X and Y on the question. Okay, so let's have a look. Menu, analyze, and you've got regression. Regression is a fancy way of saying do a line of best fit. And for our level, it's just linear, mx plus b. And you've got it there. So the only thing you need to change, you transfer this equation onto your page, but you want to change the y variable here is t, and the x variable is measuring r. So this is t equals 1.19, r plus 1.497. That's the question finished, but it's quite nice to understand what this means. The gradient means how much change on the y-axis for every 1 unit on the x-axis. Now look at the units. R is millimeters. For every 1 millimeter extra rain, we increase the temperature by 1.19 degrees Celsius. So that's the interpretation of the gradient. Okay.